I'm Alan Hall, host of the Uptime Wind Energy Podcast. Foundations are a topic that we received several requests for, and honestly, foundations are not discussed enough. Buried beneath the earth, these massive foundations supporting our wind turbines have to remain steady year after year in some tough conditions. And yet, wind turbine foundations have a great track record. However, as the wind industry expands and turbines grow, new challenges are emerging that demand innovative solutions. So I'm looking forward to our discussion with our guest, Ian Prowell, Principal Engineer with Onyx Insight. And Ian has a PhD in structural engineering plus years of experience in the renewables industry. Ian, welcome to the program.
Thank you. Great to chat with you, Alan.
So we have something in common, just to kick this off. You went to UCSD.
Yeah, I did my master's and PhD there.
Yeah, so we just visited that campus. It's quite lovely. It's a good place to get your master's and doctorate from.
Yeah, some people do have problems with focus. The waves call and they end up surfing.
Getting back on the topic of wind turbine foundations. So Ian, you have a number of years in wind turbine foundations and what's been happening on the scene. Can you just give us a brief history, like where we are today and sort of how we got to where we are?
In terms of history, I mean, what you see with current wind turbines, say megawatt plus machines, generally we're talking about late 90s and on. Early foundations, we kind of had some basic design philosophies and some ideas on how to do it. But earlier, we relied a lot on behavior of concrete and shear and intention. There were some issues that came up as things went by, and we learned due to some collapses that wasn't something we could rely on. And so, as we're moving forward, turbines are getting bigger, loads are getting higher, fatigue loads are getting much higher as we get higher capacity factors, larger rotors, so forth. And so we really have foundations now that are driven by fatigue. And that's a major design concern. And we have kind of multiple generations of foundations where early on, those foundations had initial design philosophies. And as we learned more, those philosophies were updated. And so generally, kind of era by era, we're getting more robust foundations, but also it's introducing new challenges. As the loads get higher, the foundations get larger. So, for example, concrete pours can be very difficult. They could go on for 10, 12 hours or more. And that's very challenging for the individuals out there working and maintaining, good practice while pouring that concrete for that long of a period.
And were there a consistent set of designs used back in the 90s and early 2000s, or what drove those designs? Were they just professional engineer by professional engineer designing them? And because doesn't seem to be a standard.
In the U.S., there's kind of two things coming in here. We have U.S. building code. So a foundation or a turbine tower is actually a civil structure. And so it has to comply with the U.S. building code. And then we also have all of the various rules and regulations. And so, for example, you have DNV rules, you have various rules that have been used over time. All of those rules have evolved as our understanding evolves, and the interpretation of those rules has evolved. That said, you go to any individual engineer and they will have their specific interpretation of what different provisions of those codes and standards mean.
Wow. Okay, so do state and local codes play into that also?
They do a little bit. It really depends on the location. Some locations that we're talking about installing turbines, it might be the first wind farm there. And so the local jurisdiction has little to no experience in reviewing that. And so essentially it's just up to the independent engineer review and however they're evaluating it. You do have areas, for example, like Kern County in California, who've been reviewing turbine installs since the 90s. And so they're very aware of all of the details and do get much more involved in the review.
And as we went through that big growth spurt in the 90s into the 2000s, those machines were 1 to 1.5 megawatt machines, possibly 2 occasionally. And those 1.5 megawatt machines, which are almost universal across the United States, but the foundations themselves are not universal. And that's what I'm hearing.
Yeah, so the foundation design is going to depend on primarily the local soil conditions and the turbine itself. And so if you're sitting on, say, clay or some sort of not particularly great soil, it might be a much larger, more expensive foundation. And then if you have a very competent soil, say rock, you might be able to take advantage of that rock and do something like a rock anchor, or previously we would do what were called rock socket. And so you're using that more robust subgrade to optimize your foundation size and cost.
So what generally is the most common type of foundation in the States? And, you're talking about Kansas, Oklahoma, Texas, mostly dirt, not a lot of rock.
Yeah, so most of the sites that you see going in are some type of granular soil or clay soil. And in those situations, the most common foundation, both in the US and internationally, is what's known as a spread footing. And so essentially, you see the pedestal coming out of the ground, which is about the size of the tower, maybe a foot, 2 foot larger in diameter. And then that'll go down maybe 6 feet or so and spread out into a very large, either octagonal or round footing that's actually what's resisting the overturning load of the wind turbine.
Okay, so it's the diameter of the footing that keeps everything together, and not so much the soil.
I mean, the soil's playing a part, but really that concrete footing is your main part. People will use the backfill over that concrete to provide additional weight to resist that overturning. And so that's why we bury the foundation, is so that, the soils you have on site, they're low cost, and they have weight. So you just pile that back on top, compact it. It looks nicer because you have less concrete exposed, and then you're, saving some cost.
That's interesting. And the amount of reinforcement bar or rebar that's placed in these foundations, is that by code or is that sort of engineer by engineer designed?
I mean, again, you have your code guidance on how that should be done. You have engineers designing that, and then you have different entities reviewing the design. The rebar layout tends to be very specific to the designers. You have different companies that have different preferences on how to lay things out and how they feel the loads transfer through that rebar. But yeah, you end up with kind of globally, regardless of who's doing the design right now, you've got very, very congested foundations because of the amount of rebar in there.
Does the amount of rebar that's in, and it seems to be getting more and more every picture I see of a foundation, there's just a lot of rebar and it's all cross-linked together. How does that affect the foundation itself? It seems like there's so much rebar, it'd be hard to get concrete in between the bars.
Yeah. So, I mean, essentially anyone who's worked concrete understands that you have a aggregate size. And so in concrete, like wind turbine foundations, you might have aggregate of say 3/4 of an inch, and your bar spacing might only be slightly larger than that. So it becomes very difficult to get that concrete to flow through that tight rebar mesh. And there actually have been situations where, there are known construction defects because of that. The foundation contractor constructing it wasn't actually able to get that concrete to flow and fully encase the rebar. So that is a massive challenge that we're dealing with in turbines and also other concrete structures.
I bet. And the amount of concrete that goes into these foundations is enormous. And plus they're in sort of rural locations where there's probably not a factory nearby that's making concrete. So how does that work? How does that work? You're out in the middle of Kansas, you're 200 miles from any concrete source. How do they make a foundation?
Yeah, on sites that are too far from a existing batch plant, they'll actually set up a batch plant at site. So essentially, concrete batch plants. Well, there's actually a couple ways they can do this, but concrete batch plants, they're mobile, and people can, move those to a particular site, and so the concrete will be mixed and loaded into trucks in some reasonable vicinity of the site, usually within 30 minutes to an hour of the foundation location. There are also, I haven't seen these used in the US for turbine foundations, but there are also mobile batch plants where it's essentially a truck that has the sand and the aggregate and all of the different components. And right there where you're pouring the foundation, they can mix that and create your concrete. But yeah, it's a big challenge getting concrete. I've seen sites where they've had over an hour transit time, windy mountain roads. I've seen, unfortunately, truck crashes, and so that blocked the road. And so there's lots of challenges with the amount of concrete. You're talking 80, 90, 100 more trucks transiting these, in general, pretty challenging roads.
And when they pour these foundations, say we're at some of these larger wind farms where there's 100 turbines, some of them, are 300 plus turbines. Is it one at a time? One foundation at a time, that truck running back and forth?
In general, they'll stage it. So they'll do one at a time, and the crew will move around. I think the most I've seen is like 3 in a day, but also that depends because the site conditions might be such that they, in Texas in the middle of the summer, you can't pour a foundation in 3 o'clock heat. So you're out there maybe 4 a.m. starting to pour your first foundation, so that you're wrapping up with your second foundation at maybe 1 or 2.
Wow. And what happens in places like North Dakota or Canada where it's pretty cold most of the year? You have the same problem there?
So it's essentially the opposite problem. We're adding water to concrete. We know what happens to water when it gets cold. In the extreme, they'll actually heat the site. And so in some situations, they'll tent the foundation location, heat that area so the subgrade around the foundation is heated up, and also, heat the water they're putting into the concrete and control those conditions. That's pretty extreme. That's a lot of extra money, but it can be done.
And then the concrete must vary, at least my exposure to concrete, having played around with it in different parts of the country, is totally different. It appears to be totally different. The aggregate that's in it is totally different. And sometimes the mix of it's different. How do the engineers deal with that, and the guys making the foundations? Does that play a big role in the overall design, like what the actual concrete is?
In the foundation design, you'll get a specification for the concrete. It has to have a certain compressive strength. It has to have a certain level of air entrainment. It has to have a certain slump, aggregate requirements. And then local to the site, you'll have the batch plant, the concrete supplier, actually propose a mix. And so they'll list exactly what they intend to put together to satisfy those requirements. That'll be reviewed, and often there will be test batches created and tested to make sure that those requirements are met, so that you get the air entrainment that you want, you get the compressive strength, so forth, kind of all before the actual foundations are constructed. So you can do it on smaller batches of concrete. You have less waste, and you can be more certain that you're going to get the desired properties.
Right. There's a lot that goes into these foundations, a lot more than I thought. You're talking about a lot of science and testing and rigor and engineering, re-engineering to get a site to be effective and work structurally.
When it goes wrong, it is an absolute mess trying to take a foundation out. I was going to a site and going through a crossing between Canada and the U.S., and the border guard even heard of a site that was 45 minutes away from the border about a foundation that was taken out.
Wow. All right. So then, if let's just assume we're out in let's just pick Oklahoma. We're out in Oklahoma, we're pouring foundation. We think everything has gone right. How do we know that it's gone right? What are you checking after the foundation kind of cures up before you cover it with soil?
Yeah, well, there are a few things. You try to hire a qualified contractor that has a track record and can do things. And that's one of the best things that you can do. In terms of understanding what actually happened out in the field, again, we're testing, we're tracking. Every so often, each truck that's coming to, one of the trucks that's coming to site, you'll take samples out of that. You'll test the slump. You'll test the air entrainment. You'll take samples to later test to get the compressive strength. And so all of that comes together in records for the foundation. You have oversight. So as an independent engineer, I would go out and actually watch foundations being poured and make sure that, the consolidation of the concrete was being done properly, make sure the trucks are arriving on a regular basis. All of the things that you need to pay attention to end up with a good foundation.
So, yeah, and you're the person that watches concrete dry.
I have, yes.
Well, so that happens on every foundation. So if I'm putting out 100 foundations, that same process happens on every foundation. It's not a sampling thing, it's actually every foundation.
So during construction, yeah, there are job books for every foundation, every turbine that's assembled, and you have records of all of the checks and balances that need to be done.
With all this planning going into foundations, the design and finding the right contractor and getting the right mix on site and getting the rebar right, once it's poured, everything checks out good. Then how do any foundations go wrong? Is it just because the site gets wet, or there's some geology problem, or uh, what are those things that we're looking for out in the field a year or two after the farm is up and running?
I mean, that's really where it becomes site specific. Starts depending on your foundation design, depends on your soil type. But there are some quintessential signs that you will see that are a little more universal. Definitely any sort of soil cracking, distortion of the soil, so forth around the foundation that indicates movement, possibly like gapping between the pedestal and the soil that was backfilled up against that pedestal is one of those indicators that you might be having movement or some sort of erosion through water transport. And all concrete does crack, but if you see cracking on the foundation and that cracking is growing, that can be another indicator of issues.
So is that something that technicians typically look at? Like if they're going up to do gearbox maintenance or something of the sort, when they're going up and down on the turbine, are they kicking the foundation once in a while to make sure that they're not seeing new cracks, that the soil hasn't been disturbed? Is that a routine thing?
It really depends on the site. It's not typically a routine activity. And in a lot of cases, things don't get raised up until they're fairly significant. I mean, all of us have walked by a soil crack or seen some concrete with cracking in it. And, you get erosion, you get little erosion ruts, and that sort of stuff happens. And we just don't worry too much about it, especially with a wind site where these are largely, they might be pasture land, they might be farmland, so forth. And we all know that, those sorts of places, not everything's perfect, but it's not really a problem.
See, I just haven't heard of anybody really kicking the tires on foundations. It seems like such an obvious, simple thing to do. If you're on site and something doesn't seem right, you would flag it. That doesn't seem to be the case, though, because it must be technicians probably are not trained to go look for those things yet.
The main check that gets scheduled with foundations is, depending on the site, you'll typically check anchor bolt tension on maybe 10% of the bolts on a periodic basis. And so that tends to be our standard check for foundations. But yeah, outside of that, it really doesn't get brought up until we get into a pretty problematic situation where there's very obvious and kind of gross issues.
Well, let's talk anchor bolts for a minute. I've seen a lot of videos and pictures on LinkedIn of anchor bolts that are loose, that are really loose. What does that indicate in the foundation?
Yeah, it really depends. One of the more problematic situations is you can end up with starting to have cracking in the foundation, and that cracking can cause loosening of the anchor bolts. Additionally, in certain situations, you can actually, when you're putting the anchor bolt in, it's actually just a long threaded rod. It's not actually a bolt. And so at the base, you have an embedment ring and you have nuts that attach to that rod on the bottom. And then, we see the nut on the top. And while casting the concrete, we're vibrating the concrete. And so not often, but occasionally that nut on the bottom of the anchor bolt can fall off. And so when we go to install the tower and you try to pull on that, well, there's very little holding it there. And so you can actually pull out the anchor bolt. It's much less common, but you can have embrittlement with steel. And so you could have fractures in the anchor bolts. And as they fatigue, you're gonna start to get micro cracking in them. And so that could also lead to some loosening or just, like we see in any machine foundation, as if you're vibrating it, nuts can come loose.
Let's just assume, let's set a foundation here. I'm in Iowa. There's been a lot of wind turbines put up in Iowa, and a lot of 1.5 megawatt generators been put up there. And we're doing the repowering scenario. And I'm going to come in with this new GE 2.8 or whatever this whiz bang turbine is going to be. And almost to a site, they reuse the existing foundation. At least that's what my experience has been. Is that the right approach? Should they be reusing foundations, or what are the parameters around reusing a foundation?
Well, essentially, to qualify for repower requirements, you need to reuse some of the site. And so for these partial repowers, it's almost a definition that you will reuse the foundation and often reuse the tower. If you go in and actually completely replace everything at the full repower and you're not, you're in a different situation, you're basically building a new site. Is it the right thing to do? In some aspects, yes. I mean, we have a lot of resource, a lot of material, a lot of energy that goes into building these foundations. And so, like you said earlier, we've had a good track record with foundations. We don't have a chronic problem with failures. And so reusing something that is still, usable, you're saving money, you're saving concrete, you're saving resource. The challenge becomes is now we have these foundations that were designed for a 20-year life with a 1.5 megawatt turbine on them. And now we're asking them to perform for maybe 30, 40, I've seen up to 50 years. And so maybe the engineers have designed a better control system so the ultimate loads are lower on the foundation. In a lot of cases, that's true. In some cases, that isn't. But we know that we're going to end up with more fatigue load because often these repowered machines have larger rotors. They have a higher capacity factor, and so they're running more. And then, even if they were running exactly the same as the original machine, we take something that had 20 years of fatigue loading and we ask it to operate for 40, and that is a much, much higher demand on that component. And so, yeah, it's really critical that, the review's done properly. And, I've talked about this in a lot of cases that our monitoring is done properly on that so that we catch something before we end up with, an unpleasant issue, loss of a turbine.
Right. So what are the typical steps to check a foundation? And I'm assuming I'm an electrical engineer, so electrical engineers like to check things because it's easy versus foundation people because it's probably pretty hard to do. But do you check every foundation that's going to get repowered, or is it a sampling rate that happens to see kind of what you have to start with?
Yeah. So like I was talking about with interpretation by engineers, there's different practice depending on who you speak with and what's done. It is very challenging because if you talk about, what we care about in the foundation is generally the tension components. And so that rebar, we can't see that rebar. It's buried. Even if we excavate it, we have the surface of the concrete, which isn't the rebar. And essentially we're destroying the foundation if we try to get down and understand what's going on with that rebar. And even to really test it, you'd have to extract a sample and run a fatigue test on that and hope that is representative of the rest of the rebar and the foundation. And so various things get done. I mean, like we talked about earlier, there's obviously visual inspections. There's also levels of testing that people will do because when a foundation's built, we get a specification for rotational stiffness. It's very common for the rotational stiffness of a foundation to be tested as a surrogate for the foundation health. That can be illustrative, but it is a challenging proposition because one of the things you're measuring there is the tilt of the foundation. And it doesn't tilt much. It's a very small number. And so you're taking the applied load and dividing it by essentially 0, and you end up with an unstable result. So that's real tough. And also that number was created by the OEM, by the turbine designer, to satisfy the loads analysis for the turbine. It isn't necessarily an indicator of a healthy foundation. You could have a foundation that exceeds the OEM required stiffness, but is actually damaged. Um, One of the things I've suggested for quite some time now is actually looking at the dynamics of the turbine over an extended period as a monitoring technique. And since we can do that with CMS systems, condition monitoring systems that we already have in the machine, often we can do that in an entire wind farm. And so that's a way where it's a piece of information that gives us direct insight into what's going on the machine itself. It's generally fairly inexpensive to get, and it allows us to, in much more detail, see what's going on with the entire farm and see that over time.
So Onyx Insight is obviously been in the vibration detection business for a long time and been very successful there, and is expanding into blades and now it seems foundations. And the knowledge you're getting from instrumenting foundations. You want to explain just what Onyx does there to instrument to know what's going on with foundations?
I mean, so we have multiple different capabilities, but the primary approach that we're doing is using our EcoCMS unit and taking one of those accelerometers up in the nacelle and tracking the system frequency of the turbine. And if you think about it, the turbine, it's a flexible machine. It's moving around. It has a certain stiffness, but that's sitting on top of the foundation, and that foundation has a stiffness. And so a change in that foundation will change the global characteristics of the machine. And if you watch that carefully enough over a long enough period of time, and especially over a large enough population, say the entire project, you can identify which turbines are seeing more degradation than others, and that allows us to hone in on doing more detailed inspections, possibly rotational stiffness testing like I was talking about earlier. But that's a lot more labor intensive, and being labor intensive is more expensive, and does all require a lot more skilled technicians doing the install. Where we can really we have people who can install EcoCMS, do many of those in a day. It's much more challenging to do a high quality rotational stiffness measurement.
So if you're able to instrument the towers with a simple sensor, which is what we're talking about here, a real simple sensor, and then you're just watching essentially the sway of the tower back and forth due to the loading of the blades and everything twisting and bending. You track how long of a period of time do you need to track that to know, like, hey, this foundation has a little problem, or this foundation is solid? Is it like a 6-month period, or can you tell in a day?
It really depends. So if there are gross deficiencies, foundation may be significantly damaged. And if we went through the site and said, okay, well, this is the statistical variation we're seeing in the site. We know all of the soil conditions are fairly similar, and this is one foundation design. If there's one machine that's, say, 3 standard deviations out from the frequency of the other machines, that is definitely an indicator where you would want to deal with that in more detail. We tend to work with owners and try and be more proactive. And so typically we're looking for a year plus of data, because that stiffness, that frequency is influenced by environmental condition. And so we want to see what's going on in the winter and the summer, back into the winter, so that we can get an idea of what the actual trend of that frequency is, regardless of that seasonality. So that we can take and regress out that seasonality and see possible degradation, or hopefully be able to show with confidence that there isn't degradation.
Wow. It would seem like local building codes, maybe even state building codes, when a farm is repowered, will require you to check what you have before the repower starts. So that seems kind of obvious, uh, because you are adding more load. I mean, that's the whole point of repowering, right? You're adding more load. Have you seen any movement in that direction, or just maybe the industry in general is saying, hey, we need to get sensors on our turbines a year in advance before the repower, so we know what we're doing when repowering starts?
So yeah, typically that's being driven by the independent engineers at this point. And so you have, say, DNV or UL or Sargent and Lundy or Natural Power coming in and doing a review and saying, okay, we are going to evaluate your foundations and tell us, what you're going to do to do that.
Wow. Okay. So then the insurance, thinking of where everything always ends up is at the insurance companies. So are the insurance companies kind of flowing that down on some level onto the DNVs of the world and ULs of the world?
I haven't seen a lot of push from insurance on foundation monitoring. Lenders, lenders tend to be the main driver, and the lenders are essentially the ones bringing in the independent engineers. And so they're the ones picking on the owners, saying you must do this.
Well, it makes sense though, because you're talking about such a simple measurement system with so much uh, cost savings in the future, right? If you have a foundation that goes bad, and we're going to stumble across that at some point, right? It would save millions and millions and millions of dollars for a simple sensor.
Yeah, I mean, so if you look at the history of North America, we've had about 4 turbine collapses that are due to foundation failures. And in some cases that might have been design deficiencies, that might have been overloading. There's very little information that gets shared about that because, like you said earlier, we have the insurers coming in, everything gets covered by NDA, and so there's not a lot of public discussion about those failures. I mean, there is some learning from that.
But that does drive though the lack of failures that we've had in foundations does drive what the industry does, right? But are we reaching a transition though, because we're in this new IRA bill where we're going to repower the vast majority of the wind turbines that are already in existence, which would be 50-ish thousand turbines that are going to get repowered in the next 10-ish years. Do you think is there a risk there that needs to be reduced?
I mean, that 1 in 10,000 number, that isn't even trivial, especially considering the consequence of that failure. And, if we can identify that before they lose a turbine, there are lots of things that you can do to have a better outcome if you know what's going to happen. But yeah, I do think we're putting ourselves at a lot of risk because we're taking these foundations that are older design philosophies. They're possibly lower QA/QC during construction, and we're asking them to keep operating. And, there's definitely a variation in what's being done to monitor those. And so, yeah, it's kind of a new frontier, a little bit of back into the wild, wild west when, we had overspeed turbines and we tried to throw a lasso around them and stop the blades.
Yeah, it's starting to feel like that, isn't it? Well, this is the perfect time, though, to get the word out that Onyx Insight has the capability to monitor the turbines and to detect if your foundation is secure enough to move forward on the repowering. So, Ian, you have all this data on foundations from the tower measurements and the tower swaying back and forth. What can you do with that data looking forward?
So one of the things we're looking for, like I was saying, is we're looking for that rate of change. We're looking for, are the turbine characteristics constant over time, or are they degrading over time? And if they're degrading over time, we can actually take that and say, okay, we assume that it's going to continue to degrade at that rate. And maybe in 6 months, a year, 2 years, 5 years, if it continues at the rate that we're seeing, it will statistically be an outlier at the site. And so that lets the owner understand, okay, I'm operating this machine. I'm still within what looks like a reasonable limit, but I need to get a retrofit designed for maybe 18 months out. And I need to implement that retrofit during a season where I can. Like we were talking about, concrete can be difficult to pour in the summer or the winter. And so I want to schedule that construction. And also, I want some time to have it designed, have it reviewed, and not have to pay rush fees to designers, contractors, so forth. And so having that projection of, how much longer you believe that the foundation can operate is, essentially priceless.
Oh, yeah, it's going to save hundreds of thousands of dollars with that knowledge. That's amazing.
And, we're looking for that outlier. Any site that has had a foundation failure, it's just one. And so by understanding where a particular foundation's behavior is within the entire project, it lets you say, okay, I have X amount of money and I'm going to focus that on my problems. And I'm not going to worry about those foundations that show signs of health and look just fine.
How do people reach out to you, Ian? Because your wealth of knowledge is immense, and I really appreciate you being on the podcast. So how do people reach out to you and contact you?
I mean, email works, or the the Onyx website has a bunch of information regarding our foundation monitoring offerings.
So, Ian, thank you so much for being on the program. It's so great to have another Onyx Insight person on the podcast. We've had Megan Rotondo on a couple of times, and I know Onyx does more than just blades. But so it's great to hear some things about foundations and foundation monitoring. This has been fantastic to have you on the podcast.